Hello students. In previous class, you have studied about Ohm's law and solved few numericals on Ohm's law. In today's class, let us learn about combination of resistors. In many electrical appliances such as radio, television and other similar things, it's usually necessary to combine two or more resistors to get the required current flowing through it. So therefore, there are two types of combination of resistance, that is resistors in series and resistors in parallel. Let us learn in detail about resistors connected in series. Two or more conductors are said to be connected in series if they are connected one after the other such that the same current flows through each conductor when some potential difference is applied across the combination. Consider three conductors having resistances R1, R2 and R3 connected in series across a cell which is shown here. Let I be the current flowing. So we have a current I flowing through each resistance and V be the potential difference across the combination of resistance. If V1, V2 and V3 are the potential difference across the resistances R1, R2 and R3, then we can say V equals V1 plus V2 plus V3. We know that according to Ohm's law, V equals I into R. But here we have V1 equals IR1, V2 equals IR2 and V3 equals IR3. That is nothing but potential difference across R1, potential difference across R2 and potential difference across R3, V1, V2 and V3. So what happens here? Equation 1 becomes V equals IR1 plus IR2 plus IR3, or we can take out I common. V equals I into R1 plus R2 plus R3. If Rs is the effective resistance of combinations of R1, R2 and R3, we can say that V equals I into Rs. If n resistors are connected in series instead of 3 resistances, then effective resistance or equivalent resistance of the series combination is given by Rs equals R1 plus R2 plus R3 plus so on till Rn. Here n is the resistors, n resistor which are connected in series. This shows that effective resistance of a series combination of resistors is the sum of individual resistance of the resistors in the combination. Here you can see an equivalent circuit of a series combination of 3 resistances R1, R2 and R3 across a cell. This is the equivalent resistance which is given by Rs. Remember these points. When conductors or resistors are connected in series, then the net resistance of combination is equal to the sum of resistances of the individual conductors. The current flowing through each conductor is same, or we can say same amount of current flows through each conductor. The voltage applied across the series combination of conductors is equal to the sum of potential differences across the individual conductors. Series arrangement is not used in domestic electric circuits. Suppose all electric appliances like bulbs and electric tubes are connected in series in a circuit. If any one of them fuses or breaks, then all other appliances will also not work. This is because in series arrangement there is only a single path for the flow of current. Therefore, series arrangement is not used in domestic electric circuits. Different electric appliances like bulbs, electric tubes, electric heaters, toasters and many other electric appliances have different resistances and they require different amount of electric current for their operations. If they are all connected in series, they will not operate properly. These are the disadvantages of a series arrangement of resistors. Two or more resistors are said to be connected in parallel if one end of each resistor is connected at one common point and the other end of each resistor is connected at other common point, such that the potential difference across each resistor is equal to the applied potential difference across the combination of resistors. See here a parallel combination of three resistors, that is R1, R2 and R3 are connected across a cell which is shown here. So R1, R2, R3 are a parallel combination of three resistors which are connected across a cell. If R1, R2 and R3 are three resistors of parallel combination connected across a cell, then V is the applied potential difference across A and B. The current I drawn from the cell divides it into three parts, that is I1, I2 and I3 at point A. Current I1 flows through R1, current I2 flows through R2 and current I3 flows through R3. We can say I equals I1 plus I2 plus I3. According to Ohm's law, we know that I equals V by R. Here we can say I1 equals V by R1, I2 equals V by R2 and I3 equals V by R3, as V is the applied potential difference across A and B. What happens here when we substitute this in equation 1? Our equation 1 becomes I equals V by R1 plus V by R2 plus V by R3. Let us take V common outside. It will become I equals V into 1 by R1 plus 1 by R2 plus 1 by R3. If Rp is the effective resistance of the parallel combination of R1, R2 and R3, then we can say I equals V by Rp. We can also say 1 by Rp equals 1 by R1 plus 1 by R2 plus 1 by R3. The equivalent circuit of a parallel combination of three resistance is shown here. So you can see the equivalent circuit of parallel combination of three resistances, which says 1 by Rp equals 1 by R1 plus 1 by R2 plus 1 by R3. If n resistances are connected in parallel instead of three resistances, then the effective resistance of the combination is given by 1 by Rp equals 1 by R1 plus 1 by R2 plus 1 by R3 plus so on to 1 by Rn. Remember these points. When conductors or resistors are connected in parallel, then the sum of the reciprocals of the resistances of the individual conductors is equal to the reciprocal of the net or equivalent resistance of the combinations. Different amount of current flows through different resistances. A large amount of current flows through a conductor of low resistance and a small amount of current flows through a conductor of high resistance. The total current Flowing in such a circuit is the sum of the currents flowing through different resistances. The potential difference across each conductor is equal to the voltage applied across the parallel combination of the conductors. Let us learn about the advantages of connecting electric appliances in parallel. If any one of the electric appliances or devices connected in parallel does not work or fuses, then the working of other devices will not be affected. When different electric devices are connected in parallel, the potential difference across each device is equal to the applied potential difference, and they draw the current as per their requirement and they work properly. Let us solve few numericals. 3 resistances 2 ohms, 3 ohms and 5 ohms are connected in series. What is their effective resistance? R1 is 2 ohms, R2 is 3 ohms and R3 is 5 ohms. You know that when these resistances are connected in series, their effective resistance R equals R1 plus R2 plus R3, that is 2 plus 3 plus 5 ohms, which is equal to 10 ohms. Therefore, the effective resistance of 2 ohms, 3 ohms and 5 ohms is 10 ohms when connected in series. The following combination has an effective resistance of 8 ohm. Calculate the value of R. What are the things given here? R1, which is equal to 10 ohms, R2, which is equal to 15 ohms. We need to calculate R, that is the effective resistance. Now we know that R1 and R2, they are connected in parallel. Therefore 1 by Rp equals 1 by R1 plus 1 by R2. 1 by Rp equals 1 by 10 plus 1 by 15, which is equal to 20 by 5, 150. Therefore Rp equals 6 ohms. They have given effective resistance. So we can write Re as 8 ohms. Therefore, Re equals Rp plus R. We know Re, we know Rp. Let us find out R. Re equals 8 ohms. Rp equals 6 ohms, which we have calculated. R equals 8 minus 6, that is 2 ohms. For the circuit shown in the figure, calculate the resultant resistance, the total current, the voltage across 7 ohm resistor. Here, first thing they have asked is the resultant resistance. You have seen that here 5 ohms and 10 ohms are connected in parallel. So the effective resistance of this parallel combination is given by 1 by R dash equals 1 by 5 ohms plus 1 by 10 ohms, which is equal to 2 plus 1 by 10, that is 3 by 10, or R dash equals 10 by 3 ohms. Now you can see 7 ohms and the 10 by 3 ohms, that is the effective resistance of this parallel combination. They are connected in series. Therefore, the resultant resistance is given by 7 ohms plus 10 by 3 ohms, which is equal to 31 by 3 ohms, that is 10.33 ohms. Next thing, calculate the total current. We know that I equals V by R. We know the value of V, which is 6 volts. We have calculated R, that is 31 by 3. So 6 by 31 by 3, which becomes 6 into 3 by 31, which is equal to 0.58 ampere. Next we have to calculate the voltage across 7 ohm resistor. Again V equals I into R. I value we have calculated, that is 0.58, and R, that is we have to calculate voltage for 7 ohm resistors, therefore equals 0.58 into 7, which gives us 4.06 volt. Calculate effective resistance, current and potential difference across 10 ohm resistor of a circuit. Here you can see a circuit where 5 ohms and 10 ohms are connected in series. So effective resistance we can calculate by adding these two values. Therefore R equals R1 plus R2, which is equal to 5 plus 10 equals 15 ohms. Next we have to calculate the current. According to Ohm's law, I equals V by R. We know the value of V, which is 2 volts. We know the value of R, which we have calculated, 15 ohms. Therefore 2 by 15, which becomes 0.133 ampere. We need to calculate potential difference across 10 ohm resistor. So for this we need to calculate the potential difference. We know that V equals I into R. We know the value of I, which is 2 by 15, and we have to calculate the potential difference across 10 ohms, that is into 10. Here instead of 0.133 I have taken the fraction form of it, that is 2 by 15, so that I can easily cancel it. It becomes 5 2 times are 10, 5 3 times are 15. Therefore it becomes 4 by 3, which is equal to 1.33 volt. In today's session, you have studied about combination of resistances, that is resistors in series, resistors in parallel, and solved few numericals. Thank you.